Write down an experiment to verify the dependency of resistance of a length of the wire on the length of the wire. So we have to begin the answer with apparatus. That is all the things which we are using. So let me draw the circuit diagram and then show it to you guys. So we have always draw a rectangle structure. Again, I can't lift my pen and do it. It will look too odd. So, but you guys can do it with pen and pencil and all of that. So this is where the battery comes. This is where I'm going to connect the wire and things. This is where you have your ammeter, sorry, key, and this you can have ammeter. So all this ammeter I have not told, not to the extent that is required. I just meter to read your current. So that you guys know, I guess, I hope. But the way it's connected, why it has to be connected that way, that I'll explain in time. So ammeter is one which reads the current. So A and B, mark that, and that's your battery, and this is your key, right? So so we need two wires of same length and of same material, sorry, same thickness, but with different length. So one is L and another is 2L. So same thickness, but different length. So we need two wires of such kind. This is 2L and that's L. Battery, we have that. Ammeter, we have that. Don't forget to write plus and minus. Key, yes. Connecting wires, we have connected. So what is the procedure? Connect the circuit as per the diagram. So make the circuit as per this. Connect the wire with a smaller length across node A and B. Plug in the key. So we have to switch on basically. Note down the current in the ammeter. We need to read the ammeter. Disconnect the wire. Connect the second wire 12 across node A and B and note down the reading in the ammeter. Okay. Once you note down where is that you note down, you have to note down here. So physically you'll get length, of like say 10 meter and this is 20 meter. But I'll just continue to write with variables. And the current which you read over here is going to be like say if the reading is x over here, or let me not confuse you guys. If the reading is x over there, it will be x by 2 over here. Okay. So that's how it will be. So you can write this values itself. Now, this is where you tabulate or note down the things that you did. Now the part of calculation. So we know that you guys know this, that is V is equal to I into R. Very important relationship as per Ohm's law. So next is we need a relationship between current and voltage. Sorry, current and resistance. This is a relationship. So this implies resistance is inversely proportional to current because we are fixing the constant, voltage. We're fixing it, we're not changing it. This will call it as equation 1. Now with this in mind, right, let me write I1 by I2, which is equal to x dividing x by 2. On calculation, you'll get 2 by 1. So now I'll substitute from 1. That is, in place of I1, I'm going to write 1 by R1. In place of I2, I'll write 1 by R2. So this will become R2 by R1. So if you guys are confused with that, let me do this divided by R2 by 1. Okay, this is equal to 2. This is from equation 1, right? This relationship is from equation 1. I hope you guys understood this part. So we have 1 by R1 into, this is 1 by R2. 1 by R2. So if it becomes multiplication, if this becomes multiplication, I will take the inverse of this. So this will be R2 by R1. 2 by R2 by 1, is equal to 2. So R2 by R1 is equal to 2. This will call it as equation 2. Okay. So next, one more thing is, as L1 L2 by L1 is equal to 2L by L, that is equal to 2 by 1. So what can you conclude from second and third expression? See, L2 by L1 is 2 by 1, R2 by R1 is 2 by 1. So what can you conclude from equation 2 and 3? It's clear that the resistance of a wire is dependent on length of the wire. Thus, not thus, and R is directly proportional to length. How did we conclude that? See, R2 is 2 times R1, and sorry, L2 is 2 times L1. R2 is 2 times R1. So it's very clear from 2 and 3. Okay, so this is your conclusion. This is how you should write. Yeah, it takes some time to write the table and all. If not, it's not that difficult. Right? Difficulty is not the thing, but yeah, it takes time to write all of this. So you can pause and note it down.